Let's go through LeetCode 1650. Low is the common accessor of a binary tree 3. And for this question, it gives us define the binary tree node, which has left, right, and also parent, and give us two binary tree nodes, P and Q. And let's find the lowest common accessor of P and Q. So, and also for this question, you see that this P and Q exists in the tree. So, that means there will always have a common accessor. Initially, what we do this is that we have, because it has a um, parent pointer. And I say that those kind of numbers are unique. I think are unique. So initially, what I was thinking about is that we have P goes back to root and put the value to our set, and then Q goes back again. Also goes back. Check when we need to go to the parent, check the set. If set contains the node value, then return that node. But in that case, it will need a O and space complexity. So, but we can do better. That we don't need to to have a set. So what are we thinking about is that this is a tree, right? And there is a P node and a Q node, right? P node and a Q node somewhere. And both the node, they can go up, use a parents pointer to go up, right? So optimally is that if those kind of P and Q, they are in the same depths, mm, for example, Q Q is here, right? Or Q is here. And every time they move up, they are going to meet in some kind of node, right? And if this is from here, right? When go up, eventually it's going to meet in a node. So the first place it meet will be the lowest common accessor. But that is the optimal case is that P and Q, they are in the same depth. So for example, this is depth 1, this is depth 2. But in this question, it doesn't say P and Q, they are in the same depth. For example, Q is here, right? So what we need to do is that for this Q node, we should go first to, for example, go first to this kind of range, right? To move to be the same depth of P. So how can we have this Q, the deeper nodes go first? There are two solutions, right? One is we can write a half function called get depth and return an integer. This doesn't need any actual data structure. Just use a while this kind of node doesn't equals to none, node equals node dot parents, and have a count, return this count. And for example, if we have P depth is 5 and Q depth is 10, right? So we know Q is deeper than P. Then what we do is that we let Q move 10 minus 5 first, right? Move these kind of steps. And then if they are in the same depth, let's do move up and up until they meet. So this is one of the solutions that we write how function get depth. But for this question, actually, we don't need to write get a get depth function. What we need is that um, we let P and Q go up at the same time, right? So so the things that if P and Q, any one of that already goes to the root, and another one does not go to the root, right? For example, P is already going to here, P, Q is still here. That means um, that means um, um, the P has goes to the depth P, and Q um, from the depth P to 0, right? Q is going from the depth Q minus go depth P, right? So this part is depth Q minus depth P. So that means we already get this kind of path here, right? So now what we need to do is that we put this one, go back to Q again, right? And so there are 2 pointers here. One is here, right? Let's use another color. One is here, and then another here. And this Q goes to your root is depth Q minus depth P, right? So let's go to the root again, right? And Q goes to root. It moves depth Q minus depth P. And this one also goes to depth P, the Q minus depth P. And then this Q move to root. What it do is that we let it to go to the P's node again, right? So now we'll see this pointer has moved depth Q minus depth P, right? And this one is at depth P, right? So so this one is also at a depth P. So they are at the same depth. Now what we do is that we have it go back to the root and until they meet. If they meet early, right? Not then we just return this kind of. So let's write code for this. So the code will be very simple. We are going to use a pointer called A equals P and B equals Q. So what we do is that while this A doesn't equal to B, then we're going to have A equals A. If this A already equals to none, right? That means its parent, it's already none, right? We're going to set this A as Q, otherwise as A dot parent. So what we need B is also equals B. If this is already to none, we need to set this one to Q. Otherwise, it is B dot parent. And what we return is when we jumping out of this while loop, that means A equals B. They already met, just return A. So the code is very simple, but we need to explain the how does this work. And if this one is hard to explain, right? You can also write some kind of help function. For example, write get depth, right? Get depth. And why this doesn't equals to none, as I mentioned, it just equals its parents and get depth and find P steps and Q steps. And if P step depth is greater, let P go the difference. If Q's depth is greater, then let Q go first. And then this logic is the same, right? But it's not the code is not elegant at this. We'll see the time complexity will be OH, right? We'll see height in space will be constant. That will be O1. And the Python code is very similar. So what we need is that A, B equals P and Q. while A doesn't equal to B, we'll have A equals Q. If A is none, else A dot parent. B equals P. If B is none, else B dot parent. And then in the end, return A, right?